All right, so homework 4 starts off with factoring, which you've probably done a whole ton of in your lifetime, but you get to do more. Normally when it says to factor, the first thing you're going to look for is the greatest common factor, what I can divide out of both of my terms in this case, or all of my terms if I have a longer polynomial. So if I'm going to factor this, I look at 16 and 12. Both of those are divisible by 4, would be the greatest one anyway. And then if I have n to the second and n to the third, their greatest common factor is
N squared.
n squared. It's always the lower of the exponents because you can't take out more than you have. So I'm going to divide the 4n squared out. I'm going to put that in front. And so 16n squared divided by 4n squared is 4. I'm dividing my coefficients and subtracting my exponents. Negative 12n to the third divided by 4n squared would be negative 3n. So that if you used your distributive property and multiplied it back out, you should get what you started with, and you shouldn't have anything left in common between your terms that are left in your parentheses. So on number 2, if we're going to factor 15w cubed plus 20x, the only thing those have in common would be the number 5. So 5 is going to go out in front, and 15w cubed divided by 5 would leave me 3w to the third, and 20x divided by 5 would leave me 4x. So again, if you look here, these don't have anything left in common, so you know you have it factored completely. The third one there, we have 12a to the fourth minus 23a squared. The greatest common factor there would just be a squared. It's 12 and 23 only have a common factor of 1. So if I take an a squared out of each of those, I would be left with minus 23. So again, you're just subtracting those exponents. 4 minus 2 left us 2 here, and 2 minus 2 left us no a's over on that one. So we are going to factor now a polynomial multivariate one. So if I have 26 and 6, their greatest common factor would be 2, right? I have a u to the ninth and a u to the third, so I would use the lower one, the u to the third. I have an x to the eighth and an x to the eighth, which are the same thing. And although the one has a w, the other one doesn't, so it doesn't have those in common. So 2u to the third x to the eighth should be your greatest common factor. So if I take 26u to the ninth x to the eighth and I divide out the 2u to the third x to the eighth, I'm left with 13u to the sixth. Plus, if I take my 6u to the third w to the fifth x to the eighth and I divide out my 2u to the third x to the eighth, I'm left with 3w to the fifth. So again, these shouldn't have anything left as a common factor when you're done if you have it factored all the way. Number 5 there, my greatest common factor would be what? Seven. X. Y to the third. 7xy cubed. And so if I divide out the 7xy cubed on my first term, I'm going to have just the u to the fourth left. And on my negative 28xy to the sixth, I would have u to the fourth minus 4y cubed left when I take out the 7xy cubed. And number 6, if I take out my greatest common factor there, my greatest common factor of 30 and 12. 6. And with my variables, I can take out b to the third and x squared. So I'm left with 5 for my first term.
minus 2 b to the 4th
b to the 4th and w to the 7th. So again, we subtracted the exponents, didn't leave us any variables here. Here we had 4 left. That guy didn't take any of them out, and the x squared is gone. Factoring by grouping. When you factor by grouping, you can leave it in the order that it is in sometimes, and sometimes you need to rearrange it. What you want to do is group 2 and 2 together, basically, so that you have something in common, and when you end up factoring out your common factor, you're left with the exact same things in the parentheses. In this case, if I look at this, I have a uv minus a 5u. Since they both have the u's in common, I'm just going to keep those two together, and I would factor my u out of there. If I take a u out of both of those, I'm left with v minus 5. So my goal when I factor the other two is to be left with the exact same thing in the parentheses. If I want to be left with a positive v here, when I think about my greatest common factor, in this case I want to take the negative out with it, so I'm left with a positive. So here I'm going to say my greatest common factor is negative 3 instead of positive 3 because I want my signs to flip around. Negative 3v divided by negative 3 leaves me a positive v. Negative 15 divided by negative 3 is negative 5. So my goal for factoring by grouping is to have these two things in the parentheses exactly the same, which then becomes your greatest common factor. My greatest common factor here is v minus 5. When I factor that out, I'm left with those things in front, u minus 3. And if I would FOIL v minus 5 times u minus 3, I should get the exact same 4 terms I started with. So number 8, again, I'd probably just leave those in the order they're in since 3xu minus 12x does have a common factor. And so what can I divide out of there?
3x.
3x. And if I divide the 3x out, I'm left with u minus 4. So then I'm going to factor the 5u minus 20. I want to be left with u minus 4, so what do I need to factor out of there?
5.
A positive 5. I'm going to put my plus sign since there's something in front of there. And indeed, if I do divide out 5, I get u minus 4. So the u minus 4 becomes my common factor. Yep, I can write. If I divide that out, my other factor would be (3x plus 5). And again, I'd probably just leave that one in the same order because my first two terms have a common factor of, you're all gone to sleep on me, n, right? If I divide the n out, I get s plus p. And so on my other two terms, I would want to factor out -7 because I want my signs to change, which leaves me an s plus a p. So my answer would be
S plus p minus
s plus p times n minus 7. Those were the easier ones, hopefully. So 10, 11, and 12, when I'm factoring these ones by grouping, normally I like to either put them in descending order or at least start with the one with the highest exponent. Not that you always have to do that, but it gives you a way to figure out, well, where in the heck should I start? Because I could start here, but it's not necessarily going to work. If I start with the 2w squared, and I group it with the one that has the most in common with it, then it always works out pretty nice. So in this case, I would probably group that with the minus 12w, because just because out of those three terms that are left, that would probably be the one that has the most in common with 2w squared. Out of those two terms, I can factor out a 2w. So 2w squared divided by 2w leaves me a w, and negative 12w divided by 2w leaves me negative 6. When I'm looking at my other two terms, since I want the w first in my parentheses, I'm going to put the term with the w first when I write them down. So I have the plus wy and the minus 6y. Again, I look at that and say, okay, I want my signs to stay the same, so I'm going to take out a positive y instead of a negative y. So I'm going to take out the plus y, which leaves me the w minus 6. And now what's in my parentheses is exactly the same thing, which is what I want. And so w minus 6 times 2w plus y is going to be my answer. So number 11, if I'm going to factor that, I'm going to start with the 4u squared. And what one should I group with the 4u squared? The positive 20u would be my best choice. And out of those two terms, I can take out 4u, which is going to leave me u plus 5. So looking at my other two terms, I want the one with the u first. So minus uv and a minus 5v. In order to end up with u plus 5, I would need to divide out
Negative v.
a negative v, because I want my signs to change, so I need to take that negative out. Negative divided by a negative gives me a positive u. Negative divided by a negative gives me a positive 5, so that those two things match up. And so my common factor, u plus 5, my other factor, the 4u minus v. There's probably other arrangements you could put it in and it would work out right, but I found this way, it seems to work out right every time. So that's why I do it that way. So number 12, my first term I'm going to start with is the 2u squared, since that one has the highest exponent. And which one should I group with it? Negative 14u. And I can divide what out of both of those? 2u. If I divide by 2u, I would get u minus 7. So on my other two terms, I'm going to put the minus 14u. What in the heck did they do with this one on me? That's not going to factor. Was that supposed to be a y and I just can't read? Oh, minus 14u and u. Oh, that's what, I'm losing my mind. Just yell at me. Okay, I want the uy minus the 7y. How about that? So I have the other two terms that I haven't used first. Out of those two terms, I'm going to take out a y, and it's going to be a positive y because I don't want my signs to change. I take out the y, now I end up with u minus 7. So my answer is going to be u minus 7 times 2u plus y. Factoring a quadratic with a leading coefficient of 1. A second degree polynomial is called a quadratic expression. Don't ask me why. Sometime I should look that up. Usually we factor quadratic trinomials. We know they came from all that foiling business that we had to do. If you look at the ALEX program, they put this big long table and they put these P's and Q's and they have this magic way of working it out. You can do it, it works. I just do this. I know it came from foiling. I factor my leading term. Well, w squared had to be w times w. I then determine what my signs are. If my end sign is positive, I either had to have a positive times a positive or a negative times a negative. So if my n sign is positive, I look at the middle sign and I know, oh, it had to be a negative times a negative. Then I factor my n term. I'm looking for the pair of factors that when I plug them in, technically I'm doing the outside plus the inside. It adds up to the middle. So I think about, well, what pair of factors of 20 add up to 9? 4 and 5. So that if I do my outside negative 5w plus my inside negative 4w, there's my middle term. So if I'm going to factor number 14 here, factors of x squared, x and x. My signs,
Plus.
both positive. Since the end is positive, they're both the same as the middle, a plus and a plus. Factors of 64 that add up to the 16 in the middle.
8 and
8 times 8. Now on this one, you could enter it in like that on the ALEKS program. If you do, it's going to say it's correct. However, there's a better way to enter that in, because this is the same thing twice. X plus 8 squared would be how I would enter that in. I won't count it wrong, but it will remind you that there is a better way. 15, same kind of thing, but this time my n sign is negative. So if I'm going to factor that, I'm going to say y and y. If the n sign is a negative instead of a positive, it means I had to have one negative and one positive. Positive times a negative is a negative. It doesn't matter which order you put them in if your leading coefficient is 1. Then I want to think about my factors of 6. I'm adding opposites, so when I subtract them, I want to get an answer of negative 1. So my factors of 6 that I probably want to use are 3 and 2. Since I want to get a negative, my bigger number has to be negative. Negative 3 plus 2 gives me that negative 1y in the middle. And of course, on all of those, if you weren't sure if you did it right, you could FOIL it out and check. So 16, 17, and 18, when I factor that, now I have a leading coefficient greater than 1. If that number in front of my x squared is a prime number, my factoring is a whole lot easier to do than if it's a composite number that has a whole lot of factoring. So they divided it into type A and type B. A is supposed to be easier than B because we have all those prime numbers in the beginning. But I'm doing the same kind of thing. First of all, I'm factoring my leading term. For 5x squared, 5x times x, or x times 5x, whichever order you like to put them in. My rules for my signs basically are the exact same thing. If the end is positive, they both have to be the same as the middle. So since the end is positive and the middle is negative, I'm going to have a negative and a negative. However, this is a little bit trickier because I have to think about the outside product plus the inside product. When I factor 8, it would be 1 times 8 or 2 times 4. I really don't know what pair it's going to be. I usually start with the one that's closest together and work my way up, so I have a pattern to solve. You'll see on ALEKS I'll have a big huge table of every possibility. Guess and check. If I got 2 and 4 and I want to get 14 in the middle, I probably don't want to take 5 times 4 because that's going to be pretty big, right? It's going to be bigger than my 14. So I'm going to put my 2 here and my 4 here and check it out. My outside product is negative 10x. My inside product is negative 4x. And sure enough, negative 10 plus negative 4 is negative 14, so I have the right answer. So it's kind of a guessing and checking kind of thing. It won't say this on ALEKS like that, but if you go to Linda's note sheets, under the explain or under the resources, it'll tell you what I just said. So if I'm going to factor the next one, factors of 3w squared. 3w and w. My signs, both pluses, plus and plus. Probably the most common pair of factors are 7 and 2 for 14. Which order would I want to put them in order to get 13 in the middle?
7.
The 7 first and then the 2, because you wouldn't want to take 3 times 7, that'd be way too big. Checking it, 6w plus 7w, sure enough, is 13 in the middle, so I've got my right pair. And so for number 18, factors of 3x squared are 3x and x. This time my signs, a plus and a minus. You probably don't know right away which order they should go in, so I just say plug them in. If you get the right middle number but the wrong sign, switch them around. So I'm just going to put plus and minus and go from there. Again, for 14, probably 7 and 2. Not that it couldn't be 1 and 14, but probably 7 and 2. So again, I probably don't want to take the 3 times the 7 because that's going to be pretty big. So when I check this, this is going to give me negative 6x plus 7x, and I was a good guesser because negative 6 plus 7 is positive 1. If it would have been negative 1, I would have flipped my signs the other way and got the right thing, hopefully. Problem type 2, sometimes my numbers are a little bit bigger, sometimes they're composite numbers instead of prime numbers at the beginning, so my factoring's a little harder, but really basically it's still the same thing. I'm factoring my quadratic trinomial, which came from foiling 2 binomials out. So, factors of 2x squared. 2x and x. My signs, both pluses. Now I've got 30, which has a whole lot more pairs of factors. 1 and 30, 2 and 15, 3 and 10, 4 doesn't work, 5 and 6. So I want to find the right pair of factors that when I do the outside product plus the inside product, it adds up to the middle. You already have it figured out? Okay, what do we got?
2x plus 15, and then x plus 2.
So if I check that, I get 4x for my outside product, 15x for my inside product, which sure enough adds up to 19. I probably would have went through 5 and 6, 6 and 5, and worked my way up, but eventually I would have got there. 20. It has the 6x squared. So when you're factoring that, a lot of people, since they were doing all those ones with the prime, would say, oh, 6x and x would be 6x squared. But keep in mind that I can also get 6x squared by taking 3x and 2x. And again, you really don't know when you start which way it is, except for if you do 9 million problems like I have in my life, I can kind of look at it and know. But keep in mind that when you have that composite number, that there's more than one way to factor it, and if you did their magic formula, you'd figure it out, but guessing and checking is probably just as easy. So, my signs, if I look at that, they're both going to be negative since the end is positive. Negative, negative. I'll put it in both of them. Factors of 2, well, they were nice. They gave you a nice prime number, so we know it's only a 1 and 2. Which pair am I going to plug it into, and which order does it need to be in?
The top one.
The top one?
The one with the 6x and the 2 over there.
1 there and 2 there.
Yeah, sorry.
So, I get negative 12x plus negative 1x, which sure enough adds up to negative 13. Had that not worked, I would have tried the 2 and then the 1 and then done it down here until I found the right one. And just guessed and checked till I found the right combination. But that one worked, so that's the way we go. And number 21. Factors of 3y squared. 3y and y. My signs. Negative and positive. We might not know which order yet, but we'll plug them in and we'll check it out. We want to try a pair of factors of 20. When we FOIL it out, we want to get positive 28 in the middle. 2 and 10. My outside would be positive 30y, my inside is negative 2y, and a positive 30 minus a 2, sure enough, is 28. But just a matter of guessing and checking. If you don't like guessing and checking, read the Alex explanation. They have a different way of doing it. It's just more work to me.